Welcome. Today I shall be giving some corrections to my lecture number 9, in which I did some tutorial problems on Gibbs phase rule, vapor pressure calculation and dew point and bubble point calculation. In this particular tutorial you will find that some problems were done to use the Gibbs phase rule to determine the degrees of freedom, and then we estimated the vapor pressure, and lastly we solve a problem to find out the dew point and bubble point temperatures. So I shall be looking into the last problem in which there was a small mistake in the dew point calculation. Okay, so let us go to the problem. The problem was the determination of the bubble point and dew point temperature for a mixture of 80% nitrogen and oxygen at a pressure of 0.101 megapascal. Now, in this problem, I did the solution for the bubble point calculation correctly, but a small mistake in the dew point temperature calculation, which I shall be doing now. So, let us start with the dew point temperature calculation. Now, in this, what we are given is the pressure, and because it is a dew point calculation, that means we want to find out that as the vapor is cooled at a given pressure, the temperature at which the first liquid drop is formed and what is the composition of that liquid drop. So, the given composition in the problem will be taken as Yi, that means in this case Yn2 will be 0.8, that is mole fraction, and YO2 will be 1 minus Yn2, that is equal to 1 minus 0.8 is equal to 0.2. Okay. Now, after that we have to find out the T dew. Okay. Now, to find out T dew, we have to go with the equilibrium relationship between the two phases, which is given as Yi equal to Ki Xi, and as you recall that I represents the species, in this case nitrogen, oxygen, and K represents the equilibrium coefficient, and this K value may be found out from some table like this, and this table has been given in the book by Timmerhouse and Flynn. So, from this table I have given you. So, here you can see that at different temperatures for a given this pressure 0.101 megapascal for nitrogen and oxygen, these two columns are giving the values of the K. And in case this table is not given, then what we can also do that as an approximation, we can take this particular system to be ideal, and then we can use the Raoult's law, in which case the Ki will be equal to Pi sat by P. So, in case this table is not given, that means in absence of the K value, assume Raoult's law, so that Ki may be taken to be Pi sat divided by P. Okay. So, whatever way it is, so we shall be using the K value. Now, you see that because pressure is given, so in this case the Xi, that is the liquid phase composition, becomes a function of only temperature, and that is the dew point temperature. So, what we shall do is this, we shall be now putting this particular relationship, that summation of xi is equal to summation yi divided by ki, okay, this is equal to 1, that is the mole fractions total to 1. And now we see that we shall be defining a function, say, which is a function of temperature. This we can define as summation yi by ki minus 1 equal to 0. So, this particular equation we have to solve for to get this is the equation we have to solve for. Okay. So, this is the equation we have to solve for to get the value of the temperature. Okay. And now what we do that this has to be done numerically, and for that we have to assume some make some initial guess temperature, and that guess temperature may be taken to be some kind of average temperatures of the boiling points. The boiling points, like in at 1 atmosphere, the boiling point of liquid nitrogen is 77 Kelvin and that of oxygen is 90 Kelvin. So, we can take an average, like say I say that we can take the initial, this 0 in parenthesis represents the initial guess of temperature. This may be taken as some kind of yi into Ti set. Okay. So, with this initial guess you can start the iteration, and if you find that this particular summation yi by ki is coming more than 1, okay, that means this Ft will be a positive number. In that case, what we shall do? We have to reduce the temperature. And if I find that summation yi by ki is coming less than 1, that is Ft is coming negative, then in that case we have to raise the temperature. So, in this fashion, by some adjustments within a few iterations, you should be able to arrive at the right value of the dew point temperature. Okay. So, this has to be done numerically, and there are various methods, numerical methods which you can follow to get this solution. Okay. Now, this is the correction I made, and more detail you can find in this particular references on the chemical engineering thermodynamics. Thank you.